and let's just go to shared settings. I'll just change them up. So those are separate geometry collections. I'll go just to one of them to show the settings. And yeah, you have to know that some of the settings are shared and they work instantly on all instances of that geometry collection, but some of the settings are just defaults. They are also in here in the instance settings, and if you see the same settings, it just means that here it's default. When you put it into the scene, it's gonna have these settings from here, but it's not gonna change existing objects. So for example, here, let's disable clustering here. If we save it, this object that uses the same rest collection, it has enabled clustering. The only difference is that if we move another object, it's gonna have disabled clustering because it takes this settings as a default. So this is actually the same as we talked about. It's instance settings, it's just default. Well, we are not going to talk about in this tutorial about cluster collection type. Next thing is mass as a density. So does it take mass as a density of the object, and it's gonna have different mass depending on the volume or not? I always leave it on, and guys from Epic, I saw that they too. Well, mass is mass, so the more heavy the object is, then you know. Well, actually, I'm wondering if negative mass is working. Nope. Okay. So, yeah. In Unreal 5, there is a new thing called size-specific data, and this max size. And I need to say that it just doesn't work. I think the idea was to make chunks of specific size behave differently, but it just doesn't work. And hold on a second, I'll explain it, but firstly let's go through these settings because those are actually working and they are very important. So, each geometry collection and its shared between the instances has implicit-implicit or particle-implicit collision type. And what is this all about? Well, implicit type means like a physical representation of the object. It might be a bounding box, which is a bounding box that contains the whole object. It might be a sphere, but it's not like a bounding sphere. It's a biggest sphere that fits the bounding box of the object. So if we have torus, it's gonna be a really small sphere. Okay, this torus has no fragments. It's just one piece, and I will set it to box. So it's a box right now. When we change it to sphere, maybe it's easier like this or this. As you can see, it's a sphere. Okay, now I will enable debug draw to show you how does it look like. Well, when we have a box, it looks like this. It's a box. When we have a sphere, as you can see, this is the representation of that object. Yep. So it's a sphere for the physics solver. It can be also a capsule, which is like a bounding capsule. Level set, which was used, well, always in the previous versions, but now it's replaced. It just doesn't work. It's there is no collision at all. It works only in particle-implicit mode. Wait a second. And here we always we can use Convex, and I will work with Convex because it's just like level set before in previous versions. It works just as it should. So depending on the mesh and the levels on the fracturing set. Oh, perfect. Yeah, nice. Yeah. So yeah, we will work with Convex because it just represents the mesh. One thing that you need to know is that when it's convex, so if there are no fragments, this torus is not going to go through this because there is no empty space. See the black mesh. The black grid is actually the physical representation of it. So there is no hole inside. But interesting thing is that if you have fragments, and even if they are not broken, and clustering is enabled, then you can leave convex, and if there is a hole inside, it's gonna work. Because it's gonna take some of leaf nodes. But look at this. If we have one huge part in here, oh, that's the source. That's the source object. Look at this. So this is also convex, but this piece, it's gonna be like this is convex plus this convex plus this convex plus this convex is gonna create the whole object. So there is no empty space in here. Yeah, look at this. Why it's colliding? Yeah, it's just because of that. So just be aware that you can always use convex and it's gonna be great quality always, but no holes inside the object until they are fragmented. Yeah, that's interesting, right? And yeah, this is also convex. So the next thing is collision object reduction percentage. And this is how much each fragment physical representation is going to be scaled down, and it's very useful if your object explodes at the start of the game. So it doesn't work for convex. But if we have a box, for example, as you can see, physical representation, it's box, but it's smaller, but it's 50% of the box. The same with the sphere, and probably a capsule too. Yeah, level set, you never know. Yeah, it doesn't work. I think they should make it work because it doesn't make sense. Convex. So convex doesn't work with collision object reduction percentage, but it's actually not used because it's pretty good representation. So yeah, it's useful when you for example choose box and I will disable clustering. This object should blow up just like that. And why? Because these boxes are bigger than the objects, so they're intersecting at start. They just need to blow up. On the other side, when you choose spheres, it should not blow up because the spheres are always smaller than the mesh. Yeah, but they blow up anyway. Sometimes happens. Yeah, so when you have such a problem that your meshes explode, then just play with the reduction percentage and increase it gradually until it works. As you can see, it doesn't explode anymore. Of course, you want to keep it as low as possible. Oh yeah, perfect. Yeah. So you make it higher and higher until it doesn't blow up like this. Okay, next thing is this is not that important, and damage threshold is actually connected with the size specific data, so it doesn't work. So only this and this is important, And now I will show you the particle implicit. It's actually more demanding on performance, so it's better to use implicit. But in example just like that with non-convex meshes, it's pretty useful. Well, it's wait. Yeah, it's this one. So as you can see, it's particle implicit, even though it's box. Even though it's box, it's behaving correctly because it's represented as a particles that fill this mesh. Yep. Yeah, you see? It doesn't matter if it's box or not. But it's always better to choose level set. Oh, perfect. That's what I wanted to show you. Yeah. So these are the particles that represent the mesh. When you choose particle implicit, it's the most wise to choose level set. I will always use implicit box or sphere if it's something small that user will not notice the difference and it will not blow up. But usually convex and particle implicit level set when it's necessary. But as you can see, it's when you fragment the object, you can use implicit convex and it's fine. Only if you don't want to fragment the object, you need to use particle implicit. And then choose just level set, it's always safe. So particle implicit objects also have some settings, which is min level set resolution, max level set resolution. I always leave it for default values and it works fine, except for huge objects, because then you really need to increase it, because there are like not enough particles to make the collision look good. So one time I had to change it to like 40, but it was a terrain mesh, so it was pretty huge. And there is an option to update changes manually. That is pretty useful if you tweak with particle settings, because particles are generated when you change the settings. So when I change it to 30 or 50, it's gonna calculate it, so it's stuck. And if you want to tweak all of this, it's just better to change the settings and hit apply changes once, to not wait a couple of times. Yeah, that's actually everything which is important. And yeah, so as I said, choose implicit convex or particle implicit level set, but usually the first one, and it's usually the answer for everything. Okay, so this is our res collection. Yeah, as I told you, I'll explain size specific data. Well, I told you how I think it should work, but I've played with it and it doesn't work. And look at this. For example, you want to add one element to the RI, and it always adds two of them. You cannot remove it. I don't know, it's so bugged that it's just ridiculous. So I don't use it, and just leave one here and use this, and you don't need to change this or this, it doesn't matter. I hope they fix it in a future version, because it sounds very promising, but well, it just doesn't work. So yeah, the next thing is geometry source. Yeah, it's a new option. It wasn't there in Unreal 4. And well, let's say we have an object, it's fragmented, So we have a fractured object, yeah, just like that. And we want to change our mesh because we changed something in our mesh, and we need to update our geometry collection because it doesn't update automatically. So we can just change it in here, but it won't change because we have fragmented mesh already, and it's not gonna fragment it for us. We need to reset. So that thing is, what are we resetting to? If we change something in here, we always need to reset and make our fragmentation one more time. But it's still pretty useful because you don't need to make everything from scratch, because it used to be like you need to place the mesh into the scene, set the same transform as the original one, and you don't always remember the original transform. Like in here, this cylinder was scaled to 1 to 4, and now it's 1 1 1 because it's geometry collection. It's not that cylinder anymore, and I can reset it anyway. But if I think that it's, I don't know, too high, then I can change it, reset it, and it just works, and no matter his transform. Yeah, so it's pretty useful. Yeah, but now we will have to fragment it again. Yeah. That's a nice thing, even if you just want to check what was the source mesh or source transform, you know. Perfect. Those are materials. I think you doesn't have to reset to change them. Yeah, as you can see, you can change the materials without resetting anything. Yeah, but they are shared with this. And yeah, embedded geometry. This is a new option that allows us to like stick some static meshes into geometry collection pieces, but we will talk about it later. It's a new option. Removal. That's a very useful option that allows you to remove the fragments that are not used anymore. So let's think, for example, about our old scene. So you shoot with bullets, you destroy something, and there is debris everywhere. It lies on the ground, and you don't need so much anymore. Like after a minute it could disappear to save the CPU, right, and GPU too. So this option allows us for that, but I will explain in separate tutorial. It's really great. That's everything that was important. So the most important here is just the collision type, implicit type, mass, and that's it. And the rest is in the instance settings. Yeah. Well, we will talk and use this notification events in another tutorial. Okay, I will show you a couple of tips. For example, let's make we can make geometry collection out of a few objects, and when we do so, they are separate objects in the fracture hierarchy. So they are like three separate fragments. So when we drop this object, they're not connected in any way. Until you choose max cluster level to 0, because as you can see, these three objects are on level 1. So level 0 is always just one object. Just one object. This is level 1, this is level this is level 0, this is level 1. So when we choose 1, they are separate, And yeah, and we can of course select all of them, fragment them, and they will not break until max cluster level is at least 2. Yeah, and you can of course remove the fragments, but you cannot, even if you flatten the clusters, you cannot make one object out of this 3. They are always separate. Okay, one more thing. There was a bug in all Unreal version that happened when you wanted to make geometry collection. The source mesh couldn't be rotated. It needs to be 0, 0, 0, and then you can make geometry collection. But it was in previous version because they fixed it. They fixed it, and now you can like rotate it like this, then create geometry collection, which has no rotation anymore. But this rotation has moved to the rest collection. Where is this? Here. It's this. It's here. And now it works perfectly fine. But in previous version it didn't, and the physical representation was totally screwed when you rotated something before making geometry collection. But now we don't have to care about it. One more thing. Well, let's take for example this cube. Let's say we want a glass. A glass. Yeah. So let's set a glass material. Yeah. So as you can see, it's fragmented, even though it's not broken. You need to be aware that Chaos and Unreal always renders the objects, even though they are fragmented. It always renders leaves, always renders the smallest objects on the lowest level, not like the bigger meshes. So when you have glass, it's always broken already, even you can even turn off not clustering, set max cluster level to 0, so it never breaks, but it's always rendered as a 68 separate pieces, as it says in here. Just be aware that you need to make some kind of a hack to work with glass. That's one limitation. And of course it's always worth to when you have your GC ready, to create a blueprint out of it. So then when you change your instance, your GC instance settings, they're remembered. So let's say we want a field of these objects, like 3 of them, 4 of them, for example, and this is a blueprint. So right now, if we change, if we have changed this to like kinematic, it just changed in one instance. But if you change it in your blueprint, then they are all gonna change. So I always prefer to make geometry collection and then blueprint out of it, because you never know how many objects you will place in your scene. And then when you tweak your damage threshold, for example, you don't need to, you know, search for all cube geometry collection objects on your scene on all the maps and change the same setting. It's just easier to do it in one blueprint. Yeah, I think that's all for now on. That was quite a long tutorial, and I hope you liked it. If you want to support me, then subscribe to my channel, comment, leave a like, and I will bring you more tutorials. Yeah. Okay, I have just killed my computer with 1000 donuts. Yep. But if we change it to not particle-implicit, but implicit-implicit, then it works much better. Yeah, particle-implicit is very expensive. And if you change it even to box, then it's just very fast. Yeah. Okay, I hope you like it. Subscribe and see you.